minutes of requests. So we've packed in the agenda. So I hope I'm going to breeze through the status as quick as I can. Please read the note well. You're bound by it. It talks about the fact that you need to be professional, that you need to know that when you participate, you have IPR constraints, and it needs to know that this is a procedure uh, that is forwarding the internet goals. Read the details yourself. Okay, its status, IDR status is on GitHub. Look at it. It's probably interesting more than I am. You know, you can read the status, but I'm going to give you the 2-minute brief detail. We sent to the ISG the draft ITF IDR VPN ORF. We are in the middle of post IDR Shepherd write-ups on 6 additional drafts. One is draft ITF IDR SR policy NRP, which I expect to go quickly. So with draft ITF IDR and NHC and derived community. The other 3 will take a little tweaks, but we have every confidence that within a month we'll have another 3 at the ISG. Bon appetit, Ketan, for reading. Okay, there it goes. But what we really need your help on, if you want an adoption call for new things, please comment on these existing calls, because we need to finish them up in order to get to adoption. So please comment. Even if it isn't your draft, the best way to get your adoption draft out is to help us get the working group last call. That we work in order of post working group last call to the ISG, working group last call, adoption. If you want your adoption, please comment. That's my plea. This is the schedule. The schedule for today is on the web, so the rest follow along as you can. We have a data center focus in the beginning. After that, we have flexible interdomain algorithms for SRv6. After that, we'll have a bit of multicast from Jeffrey Zhang, and then we're going to swap over to SID list optimization with Zafar. Zafar, are you here online or are you here in person? Okay, we'll find out. Hopefully it's fun. And then last, we have security. At the end of the day, after you've got all your coffee, we're going to have a charter discussion. Now, brief news, and then the rest of the week, I'm going to hold on Wednesday, that's tomorrow morning, editing for those who have FlowSpec V2 drafts, because we expect in April and May to finalize on the base draft and then start adopting. And we have a lot of adoptions. And on Friday, we'll have a core, in the core area, there's a proposal for an interface capability on the open, multicast information, SRT drafts, BGPLS drafts, NRP exceptions, SAVNet, BGPLS, and FlowSpec. So you don't want to miss the week. It's going to be full of fun. Okay, charter. Maybe you get bored in the middle of somebody's talk. Might be mine, you know. But there's the charter. Look at it. The style of the charter is different. Every ISG is different. In case you didn't know that, different group of people, different group of requirements. So they make different charters for us. So this one has a detailed. 5-6 years ago, they wanted less detail. I don't care. We just give them what they'd like. And what doesn't change? The 2 implementations isn't changing. The work we're doing isn't changing. They're just giving you a wonderful detailed list. But read it. Maybe it'll be fun. So one concern we'll talk about, because lots of you have come up and talked to me about, is how does a IDR maintain a good BGP protocol with scaling and interoperability when a lot of AFI-SAFIs shove information through it. So I've had the comments there on the bottom. This information has nothing to do with routing. Why is it in BGP? Why do they get to break BGP and we suffer? This is the time to expose your comments. The work hasn't really changed, but if there's something we need to know, this is the time. You can talk to me, you can talk to G, you can get online and talk to our Kay or Jeff. Okay. Um, next, it's Kevin. All your turn.
You want me to
Can you
switch the slides? Change slides. I can do
Did you get the slide back? Yeah.
Good afternoon. My name is Kevin Wan. I'm from Juniper Networks, which is now part of HP.
Just a minute. Do we have it up?
The draft I'm going to talk about is BGP
Okay, I'll get it. Hold on.
deterministic path forwarding,
Ready?
DPF.
Okay,
Yeah,
it's this one.
Right.
Mhm.
Can you click on it?
Yeah, I've got the slide, so I'm in the wrong
this is
place.
manage.
Yeah.
It's not
Okay, just a minute.
share slides. Use a share slide.
Okay.
Let me share it.
Hmm.
You need to take back
Okay.
control.
Just a moment for some technical difficulty. Do you have it?
Let me try.
Okay, you've got it.
Let me try this. Okay. Should work.
All right. I think I'm done with this slide.
Click.
You have to give him the, yeah, yep.
Add it back. How
Okay.
about now?
Yeah, now it's working. Okay. All right. As we know, today's data center usually use the Knot topology with IP forwarding, and usually BGP is the only used routing protocol. So this design is simple. It's designed simple for a reason. It's just because for reduce the cost, maximize the interop. But whenever you go simple, there's always some limitation. So here in the simple design, all of the flows, you don't really have control. It's usually randomly hashed to
Young model will be
maximize the ECMP at every stage. And BGP DPF on the other side is trying to separate physical
Screwed up.
IP fabric into multiple logic fabrics or conduit fabrics. And then we can map flows to different conduit fabric to achieve node balancing or differentiated SLA or avoid fit sharing. It is a lightweight traffic engineering for IP fabrics. To further explain DPF, let me use a few use cases to see how we can use it. The first use case is called QPL pinning. This is a use case in the AI ML fabric, where today, when one GPU wants to send data towards another GPU, we usually use the RDMA, and the Rocket V2 can be used to send those flows. And when you send a big chunk of data, we also allow them to partition the big chunk of data into n number of equal amount of smaller chunk for better granularity. So each chunk is identified by a QPL in the Rocket V2 header. So if we map different flows into different conduit fabric, in theory, we can make sure each of the conduit fabric has perfect node balancing. So this will help avoid the congestion proactively. A second use case is for the multi-tenancy for GPU as a service. Let's say we have a red tenant and a blue tenant, and they may have different SLA requirements, and they may pay different prices. So let's say the fabric is partitioned into a red fabric and a blue fabric, and we map the red tenant towards the red fabric, the blue tenant towards the blue fabric. This way, their traffic will be isolated and they will not interact with each other. And we could achieve different SLAs for different categories of tenants. There are also cases where people may want to avoid fit sharing. One such example is again in the AML fabric. You may want to map your instruction flow towards the green fabric, while your data flow towards the red and blue fabrics, so that your exception flow don't share the same fate as your data flows. The other use case is in the factories. People usually use the PRP, which stands for Parallel Redundant Protocol, to control those robots. And what PRP do is it try to replicate each packet into two identical copies for redundancy. In case one copy is lost, your robot is still working. However, this kind of redundancy only works if you can make sure both copies go through disjoint paths. So in this example, if we map one copy towards the blue fabric and one copy over the red fabric, you would help to maximize the redundancy. The way we kernel the eBGP session, the way we kernel the fabric is through kerneling the eBGP sessions. And we attach our kernel community for the eBGP session. So if we want to kernel the link from spine1 to NIF2 as red, then we just kernel the eBGP session on top of it with a red kernel community. And then after the session is kerneled, it only allows routes with the matching kernel to go through. The only exception is for those unkerneled route, which is usually used for the protocol control packet that can match any fabric. There are two modes when we kernel the session. The first mode is strict mode, where we use a session kernel capability in the BGP open message to negotiate. So let's say if you configure a red session as red on one end and accidentally configured as blue on the other end, so the negotiation would fail and we would not allow the session to come up. So this works good because you detect the misconfiguration earlier. But the disadvantage is like with today's negotiation, you would have, whenever you change kernel, you need a new open message. You have to flap the BGP session, unless you do the dynamic session capability, which is not so popular today. So to address this, we also allow a loose mode where you do allow those misconfigured sessions to come up, but rather you rely on the route kernel matching to detect the misconfiguration. Let's say again, if it's configured as red on one end and blue on the other end, so a red route would be allowed to advertise on the red end, but once it's received on the blue end, it will be rejected. So once the sessions are kerneled, now we can kernel the route so that you can specify the intent of how do you want to send the route. The simplest case is like each route just assign one kernel. In this case, I have two routes, one assigned with red, the other assigned with blue. And the red route will be sent over the red sessions only, and the blue route will be sent over the blue sessions only. So at the ingress, you would see like the red route is going through the red spines only, and the blue route is going through the blue spines. Under certain cases, people may want, like, in case my red fabric fails, I don't want the packet just to be dropped, right? So in this case, you can specify a primary kernel and a backup kernel. In this case, the route and NIF2 is specified as red as primary and green as the backup. So what we do is we send the route over the red session with the red community. In addition, we also send the route over the green session with the green community. And we also use AIGP with metric 0 starting from NIF2 to tell the ingress or intermediate node that I want red to be my primary. So in this case, on NIF1, when both paths are received, it will know that red is my primary and green is the backup. There are also cases people may not want just a single kernel as a backup. The reason is because when your primary fabric fails, suddenly all of the flow used to go through the primary fabric now will be dumped to a single backup fabric, which might easily cause congestion on that backup fabric. So to avoid this, we have a mode where you can specify one kernel as red, and you specify the rest of kernels as a white card as a backup. So in this case, the route on NIF2 is sent from the red session with the red community and the AIGP of 0, and is also sent over the green, the blue, and the purple fabric with the corresponding communities. So now at the ingress, you would see the primary pass is just one kernel, while the backup pass is a ECMP over 3 kernels. So in case the red fabric fails, the red flows will be evenly, or at least like intended to be evenly, hashed into all of the rest of 3 fabrics, so that each of them only take a fair share of backup without causing congestion. The last mode is you could also signal a route with all kernels, which is very simple, like send over each of the kernel session with the kernel community. And at the ingress, you would see our ECMP, which is not very different from today's best effort route, except that it clearly tells you the kernel of each next hop. So ingress could use tools like file filter to decide which kernel to map which flow, and with the rest kernel as the backup. Yeah, this will end my presentation. I'm able to finish it. So as I said, this draft has just been published last December, so it's currently version 0.0. We
Jeff,
got
do you want to use the clicker thing? I've got Nan in front of you on the queue. Nan, did you want to get to the mic? You're in the queue.
some commands, and which is already which is going to be incorporated into the next version 1, after this IETF. In the meantime, we do welcome comments as well as contributions. Thank you.
Hello, Nangong from Huawei Technology. Thanks for your introduction. Just a small question. Uh, uh, Maybe there are already some routing policies on our routing nodes. So, are there any influence on the existing routing policies if we use the color mechanism? Thank you.
Yeah, very good question. So first of all, the intent of this is, like, as I said, this kind of data centers usually people want to keep it as simple as possible. So the intent is to minimize policy. However, if you do have policy and this kernel, the policy would take the precedence over this kerneling. So I may kernel a route with red, but if you use that explicit policy to modify it as green, then your policy will take precedence.
Next we have Sandy. I think it's Sandy Zhang.
Yeah.
Yep.
Sunny Zhang ZTE. It looks to me it's like introduce multi-domain, multi-plane in BGP. So from my personal perspective, I think that FB can only control it by the extended community for the route, not for the session. So maybe it's more flexible. Please consider about it.
And let me try to see whether I got a question. So you do know that we kernel both the session and the route, right? So you are, what is your suggestion? Can you repeat it?
So because maybe I see the first version of this draft, it looks like all the BGP session can be built by color community, right?
Right.
Yeah. My question is that maybe we can just consider for routing restriction for the contribution or just the computation, not for the session review establishment.
Yes, that's what I'm wondering whether what you're talking about is like the loose mode where we don't control the session establishment based on the kernel, right? So we do allow you to come up, even if it's mismatching, but instead we just map your route towards the kernel of the session on both ends.
Okay, and it looks like in the strict mode, the session will be controlled by the color, right?
Yeah, that's correct.
Yes. So that's optional, and we can choose to not to broken the establishment between the BGP pairs, right?
Exactly. Yeah.
Okay, thank you.
So, and also in the future, I know that we have a pretty old draft talking about dynamic session capability. So once that's getting more popular among vendors, we could use that to dynamically negotiate without flapping the session.
Thank you.
Jeff, it's your turn. I took myself out of the queue.
Just ensure NVIDIA, the backup, is it a BGP constructor data plane?
Yeah, Jeff, you need to back up a little from the mic. It's a little hot.
The backup route, is it implemented as construct in BGP, or you need to run best path to use backup routes, or you download all of them, you create two next subgroups, and one is primary, one is backup? Where is it implemented?
You mean like this example, right?
Yep.
You have a primary and backup. So where is it implemented? Well, I think most of the routers today, they do have the capability to have like FRR, right? They do have capability as of the primary next hop and backup next hop. So if that is the question, it's implemented in the routing protocol daemon itself. Of course, different vendors have different details.
No, so more specific question, would you accept all colors in BGP? They would be installed lower as same cost, and then due to difference in community, you'll create two different next subgroups.
Oh,
Is it
okay.
correct understanding?
Okay, I see your point. That is very much implementation detail, and even to be honest, even within HP or Juniper, we have different ideas.
Okay, I'm
So-
gonna have to ask you to take this to list. I'll ask you to answer why with all on the list something for me, since we don't have time. Would you answer why you went to a router open capability when we have a lot of other color mechanisms? Just why you went that direction? Okay? I'll send the question to the list.
Sure.
We're out of time.
Yeah.
Okay, Jeff,
Can just 20 seconds? I think you need to be very specific, because in first case, you're going to advertise the routes to your peers.
Over
In
to
second
Jeff's
case, you won't.
slides.
So it has to be in standard track document. You cannot just keep it as private detail.
All right, I will talk to you offline.
Okay, we're gonna go to Jeff Haas's slides. Thank you. Jeff, you should have control.
Okay, good morning. This will be a very brief update on the BGP Yang model. And I'm waiting for the clicker control to be passed over. Otherwise, you could just simply hit next if you want to.
I need to hand the control to you.
You have it.
I can do it for you. How about now?
Should be
Okay. So our prior status, we had last gone through a last call and a bunch of edits back in April 2023. We ended with weak support. Yang models are very complex and very difficult to review, so this is not terribly much of a surprise. We did publish version 18 in October to try to address the little bit of calls that we actually had. And we moved into waiting for implementation because we normally require two implementations to do things. That said, why are we doing anything at all? Well, the Broadband Forum liaison asked us back in November that they wanted to make use of the BGP model to do some of their own work. We also have seen very recently another draft from NMOP that will want to also try to make use of this work. And our current AD basically said, no, let's actually get this thing published. Well, this means we're shipping things without implementations. So we spent some energy doing a bunch of last-minute cleanup, audit versus the existing open config models and a few other things. What this ended up doing was resulting in an eye chart of about 48 different small items that were fixed across the last couple of weeks. So if you care about the details beyond what actually shows up in the RFC diff, please feel free to take a look at the GitHub for the draft. And you can take a look at all these little micro details as we work through the process. Sort of the high-level important changes that most people would care about, there have actually been some reorganizations. This would be considered a breaking change if this had been a published model. Mostly this changes where some of the leaves are present. One of the things that we spent energy to get correct, thanks to Maria and Mahesh, is getting the regular expressions for communities updated. That should actually be addressed now. The filtering language that we published in the last version now actually has a ABNF, so it should be possible to implement a version of that if you don't have code that currently understands REP 181, style AS path regular expressions. And for everything else, please see the data tracker diff. What is left? Well, the draft Natana that you saw from EdMop earlier on, basically it pointed out that we are using submodules which have some level of controversy within the Yang community as to when they're appropriate to use. One of the side effects is they're effectively a private include within Yang, and the side effect of that is that you can't use them external to the namespace of the BGP module. The Natana draft is looking to expose these things, so we have been encouraged to basically open that up. There'll be a little bit of continuing discussion with authors from them to figure out exactly what work they're looking for and to quantify what's being done. And that set of conversations, along with the pressure from AD and the general community, will determine whether we ship this thing to RFC before addressing these things or not. The goal is to try to at least address the points. Past that, it's decide whatever is left to review. And the sort of last point for myself, I've been working on this for several years at this point, and I am looking to stop having this haunting me. So I will be hanging up my hat for the IETF BGP Yang related roles at the end of this draft once it's been published. We have maybe 30 seconds for questions if anybody has any. Otherwise, let's take it to the list.
We have no one in the queue. Anyone would like to ask questions? Okay, we'll go on to the next speaker.
Yep, thanks, Sue.
You got it?
Good afternoon, everyone. I am Zhuang Rui from China Mobile. Today, I'm going to introduce our draft named BGP Port EC for AIDC. So first, I will introduce the background. It is well known that in AI data centers, AI tasks are highly sensitive to congestion and packet loss caused by congestion. As on the network side, as we can see in the picture, the gray area, we have various methods to minimize the congestion and packet loss, such as packet spraying among multiple equal cost passes. But when it comes to the endpoint side, when multiple AI tasks are executed simultaneously on the last hop, as we can see in the picture, the link between the destination leaf switch and the destination server, there will be many traffic aggregated at the same hop. So this resulting in serious packet loss due to congestion. So we need effective method to avoid last hop congestion and improve the efficiency of AI task execution. In some implementations to avoid last hop congestion, the sending side will negotiate with the receiving side's leaf switch before sending traffic. For example, in the picture shown before, server 3 needs to negotiate with leaf 1 or leaf 2 to send traffic to server 1. This means the source server cannot send traffic until the receiving leaf switch allows it. Only after the receiving leaf switch grants permission can the sending server begin sending traffic. According to the existed implementation, the sending side source server or leaf switch needs to know the port ID between the destination leaf switch and the server in advance, so as to negotiate before sending AI task traffic. So we need to allow the sender to negotiate based on the information needed before sending traffic. To achieve this requirement, BGP needs to be extended to include port information on the destination leaf switch. This is also the main contribution of the main work of this draft. So here comes our proposed solution. The main contribution of this draft is to leverage BDP extended community attributes, and we design a new subtype which carries the port ID between the leaf switch and the server. So we can see on the left, there are two pictures. These two pictures give the format of the BGP extended community attributes. There includes two kinds of format, including transitive IPv4 address specific extended community and transitive IPv6 address specific extended community. In those formats, the subtype it indicates that this is the root port ID extended community, and the global administrator, it is set to the IPv4 or IPv6 address of the switch that advertises the server root. This address can also be used as the loopback address for establishing the BGP connection. The local administrator is set to the ID of the port connecting to the switch and the server. With such design, when the leaf switch advertises routes to the server, the advertisement includes the root port ID extended community, which is transmitted along with the root advertisement. Upon receiving the route carrying the root port ID extended community, the leaf switch will check if the address is reachable. If it is reachable, the extended community will be ignored. If it is reachable, the address and the port information will be stored locally or sent to the server. We should know that the storing or sending procedure is outside the scope of this draft. There are something we also need to know. First, the advertisement scope is limited to one port. Second, because there are a large number of ECMP links in the network, so the add path function needs to be enabled to ensure that the route is not aggregated and thus its information is not lost. Here we give a simple example. As we can see on the right, the picture, this picture shows the procedure of negotiation between server 3 and server 1. First, the routes advertised by leaf 1 and leaf 2 to server 1 carries the root port ID extended community. Then when server 3 wants to send AI task traffic to server 1, it should first negotiate with the leaf switches connected to server 1, such as leaf 1 and leaf 2. If leaf 1 is successfully negotiated, traffic will be sent to server 1 through leaf 1. If the negotiation with leaf 1 fails, it will further negotiate with other leaf switches, such as leaf 2 in this picture. So this means when a server wants to send large traffic of AI tasks, it will negotiate bandwidth with leaf switches first based on the destination switch and port information obtained from BGP. Then traffic will only be sent after successful negotiation so as to avoid packet loss caused by congestion, as we mentioned before, many to one congestion. We should notice that the negotiation process is also outside the scope of this draft. So that's the main work of the current version of this draft. In the future, we are planning to enrich and improve our draft. So if you have any valuable comments or valuable suggestions or have better ways to advertise this port ID, please feel free to suggest and discuss. Thank you very much.
I don't see anyone in the queue. Would you like to add some? Kriti, will you put yourself in the queue? But come on in. Jeff, if you're next, just stand up.
Did I not put myself in the queue?
Yep, go ahead. Don't worry.
On the problem statement slide, you have a statement that says BGP needs to. I don't think BGP needs anything. Just saying.
Thank you. This is just we do some work about the BGP extended in our global Ethernet.
No, I understand the problem statement. I understand that the ingress might need to know what the port is, but it doesn't have to be BGP. That's all I'm saying.
Yes, thanks for your evaluation. valuable suggestion. We also consider using some other valuable ways to fulfill these requirements. Thank you.
Just ensure NVIDIA. So I assume you'll be attaching community to redistributed subnet that identifies the link from leaf switch to the server. When you reach particular scale, you would really like to aggregate all the routes on the leaf, right? You go towards 100,000 endpoints, your routing table becomes unmanageable. How would you deal with it?
Sorry, I didn't fully understand your question. Can you explain it more specific?
Sure. You attach community to a route, right? That's the vehicle to distribute communities.
Can I ask you to both?
I'll do it offline.
Yeah, thank you. Maybe you can talk to him afterward and discuss that. We're just tight on time today. So Jeff, if you would do that, I appreciate it.
Sure. Just explain how you would aggregate routes while still using it.
Thank you.
Hello, everyone. I'm Xiaohu from China Mobile Cloud. This talk covers brief update to fair using BGP draft. Major changes since the last version, adding a new cursor, adding a consideration about a multi-homing scenario. In previous version, there are no special consideration about multi-homing. For example, in this topology, as shown in this figure, when leaf 1 received 2 ECMP routes from SPI 1, SPI 2 respectively, although those 2 ECMP routes are associated with different path bandwidth values, leaf 1 will calculate the same weight for both routes. The reason is that leaf 1 will simply determine the weight by calculate the minimum value between the bandwidth, the link towards the advertising node, and the path bandwidth value associated with the received route. Now, with special consideration for multi-homing, for the same topology, for the same ECMP routes, leaf 1 will calculate different weight values for those 2 ECMP routes. It occurs because leaf 1 will double the bandwidth link value, the bandwidth value of the upstream link towards the advertising node before calculating the minimum value between the bandwidth of the upstream link and the path bandwidth value associated with received route. In this way, the total bandwidth resource can be more efficiently utilized. This is very important for AI networks. Currently, there are at least 2 vendors have implemented fair using BGP protocol. In addition, there have been at least 4 mainstream switch chips which can already support this protocol. The co-author of this draft believe the current version is draft is ready for working group adoption call.
Any comments on this one? Just go to the mic.
Yeah, Stefan from Cisco. I think this is a comment that I already made. What is the justification to create a new extended community to do that, while we have already multiple vendors that do that with the existing link bandwidth community.
Okay.
And the use case is already solved.
Okay. This is a good question. This question
Thank you.
have been discussed many times when I negotiate with some vendors about this protocol. The reason for using or inventing this new extended community is when we build 5-stage cloud networks rather than 3-stage cloud networks, the single link bandwidth extended community is not enough to accurately identify the.
Why? It's just a carrier. You could put whatever value you want in it. It could reflect just the local links that you have. You can accumulate. All these things are already done.
Okay.
An extended community is just a carrier.
In a word, I have discussed with one course the link bandwidth draft, and after discussion, he also admits the necessity of this new pass bandwidth extended community.
But look at the eBGP DMZ draft. It already defines some of the use case using the link bandwidth community.
Okay, we can talk offline.
Yeah, absolutely. But my worry is really, we will just over-complexify things. You will end up into possibly receiving BGP updates with link bandwidth community, plus this one, you will have to do some magic between the two. Honestly, why?
Yeah, many vendors also don't realize the necessity of this new extended community. But after deep discussion, they realize the single link bandwidth extended community is not enough, especially for the 5-stage closed network.
Go ahead, Jeff.
Sure. So 200% agree with Stefan's comment. I think you really need to provide justification. The DMZ community is deployed at huge scale already. It's deployed everywhere. Replacement is an expensive operation. I think it's also interesting if you have both, how do they interact with each other, right? Because you need to migrate eventually. All of this need to be in the document because cost of change is really significant, right?
Okay, let's talk about a brief update of the current version. If you are interested on the original motivation for the pass bandwidth extended community, we can talk offline, okay?
No, it's not okay.
Okay.
It's deployed at scale. If you want to propose something new, justify it.
You can imagine if you can imagine whether you could use a single link bandwidth extended
I need
community
to
for
warn you.
5-stage closed networks. Okay.
Oh, are you good? I'm sorry, guys. Are you going on to the next presentation? I wanted to have you not run out of time. There you go.
Okay. This talk covers brief update to the BGP neighbor discovery. Major changes include addition of new cursor and addition of a new scenario, the use of OCS within data centers. The use of OCS within data centers is becoming popular, especially for AI scale-up networks, where the SPI switches within leaf SPI topology could be replaced by OCS devices. Reason for this choice include, but not limited to, a higher reliability and lower power consumption, since there are no OEO transition and there are no optical modular on OCS devices, and it could support very good multi-tenancy isolation. Given the dynamic reconfiguration between dynamic configuration that links between leaf node in this topology, it would be beneficial to use BGP neighbor discovery mechanism especially for network automation purpose. Till now, there are two vendors have implemented this protocol. More implementations are on the way. Here I will show some details. You can see BP neighbor discovery enabled on the adjacency interfaces of two adjacent devices. Lookback addresses used for BP session establishment is workable. Route to peers lookback addresses learned where the BGP hello messages. The route to peers lookback addresses are installed in the routing table. And now BP session could be established with the discovered peers. Co-authors believe this draft is also ready for working group adoption core. Any comments?
Go ahead, Stefan. We're real tight on time.
Yeah, just one quick comment, and it's more for the chairs. Is IDR charter to create protocols that are not BGP? Because it's helping BGP, but it's not BGP protocol.
This one has a history when we had the, when we were taking BGP auto configuration. I don't know that we're going to be back in the business of doing BGP auto configuration again.
Yeah, because especially as part of the discussion of the new charter, this needs to be clarified. I would say.
Because it has a history, I let it be presented, but we don't have, we put that area of work away. So I'm not sure we can go ahead and adopt it, but it is appropriate for people to see it as it was something we've done in the past. Okay. I mean, that's where we are. And yes, we're in the middle of a charter discussion, so you can vote with your charter discussion as well. Okay. Next, any other comments? We'll go on to the next slide. Thank you.
Okay, thank you.
Hello, everyone. I'm Lian from China Mobile, and I'm glad to be here to present our draft on behalf of all the co-authors. And our draft is related to the BGP extension for interdomain flexible, and it's applicable to the SRv6 data plane. And this is the first time for the presentation. So first, I would like to introduce the background of this draft. IGP Flex Algo provides a mechanism for the IGP nodes to calculate the path based on some constraints, such as low latency or high bandwidth. And SRv6 can serve as one of data plane solution. And in SRv6 network, the traffic often cross multiple domains with the same constraints. So even across the domains, the traffic or the path still needs to meet the same constraints to meet some requirement. So this leads to the key point of our draft. How can we keep the flex algo consistent across the domain? Our document proposed the BGP extension to advertise the SRv6 locators together with the associated algorithm across the AS boundaries. Here is the typical scenario from the picture. We can see that the AS1 and AS2 belongs to the same network operator, and we need a low latency path between the router P1 and the P2, maybe for some certain service. And in both domains, the flex algo 128 is defined with the same metric, for example, the low latency, the latency. And in AS2, the oh, sorry, there is a mistake on this slide. It should be the P2 router. The P2 router advertises the SRv6 locator through the IGP flex algo, and through the redistribution between the IGP and the BGP, the PE1 router in the AS1 can learn this route. But the key point is that node PE1 only learned this route from the IGP short path, and it does not know this route is related to the flex algo 182. So we extended a new community and to carry the algorithm information and with the prefix in the IPv6 unicast NLRI, and we call it the Flex Algo Extended Community. And this community is a transitive opaque extended community. And the format is very simple too. And there is one, there is 8-bit to fill the algorithm information. And also we need type low to define from the INR. And this is the first version, so we appreciate all the commands, and we will update the draft accordingly. Thank you.
Yeah, Krishna Swami, Cisco Systems. So have you looked at the RFC 9273?
Yeah, I know it.
Right? So, you know, the color can be mapped to an algorithm. So do we really need an extended community to carry the algorithm information?
You mean the BGP car?
Yeah.
Draft. RFC. It's already a RFC.
No, not the car. The color.
CPR.
Color prefix routing.
CPR.
Yeah, CPR.
Yeah. The authors, we have read this draft carefully before we propose this draft. We think that they are different because this that RFC illustrates the situation of the policy, the policy scenario, but it's that's not suitable for the flex algo scenario, as we think.
See, the thing is, with the color, you could map it to any algorithm, right? So why do you really need one more method to carry the flex algorithm in the extended community?
Maybe color is one way, but I think that the CPR RFC cannot suit this scenario.
And hi, I'm can I first? Okay, thank you. And I'm Yujia from Zhongguancun Lab, and I just have a question about the interdomain semantics of the algorithm idea. Because if we have two domains and both use the flex the algo, but the assign different meaning to the same ID, do you expect a stricter coordination of those IDs across domains? or some form of policy translation at the AS boundary?
Thank you for your question. And it's a good question, I think. So first, I want to elaborate that here, in this format, the algorithm is not only the algorithm ID. It can be the algorithm type as defined in the RFC. If I didn't remember wrong, it's RFC 8665. It's an algorithm type, not only the ID. And you can choose which one to use. And second, I want to say that if the AI is under the same operator, usually we will operate the same algorithm with the same metric type calculation algorithm. But yeah, you are right. It's not it's not certain. It's not a certain way. I think maybe it will be different.
Yeah.
So you can use the algorithm time, or other. There is another way. If for example, the algorithm has been applied on the different AIs, and you need to realize this function, you can static configure the mapping of the flex algo to achieve this. There are many ways to realize that. Hope this can
I'll be
answer
very
it.
fast.
We're running to, but if you could make it brief, we'll.
Yeah. In fact, what she was highlighting is really the reason why CPR was done. Because
Yes.
in a generic multi-domain, you cannot guarantee that the same algo type has the same meaning. So you need this kind of translation. But I fully agree. If you are in a kind of multi-domain under the same administration, an algo could work. Your proposal is okay. It's just that it's not generic. I would say while the CPR one is generic. So if you want to continue, you need to refer to CPR telling that your proposal is an alternative, but it just works for one simple use case, which is a common administration. But CPR is really the ultimate solution to solve this.
Yeah, thank you. Understood. Only quick answer. I think the CPR or the CAR is a general purpose framework for the intent-aware routing. But our solution is more simple, and it's incremental method to just realize the algorithm scenario. Thank you. If I didn't answer you very well, we can discuss it on the mailing list.
I'm really.
Thank you again.
If you would continue this on the mailing list, we've got to go on to the next person. Thank you very much for presenting. Jeffrey, you got to be tight today. Okay.
All right, so I'm presenting this BGP signaling for multipath traffic engineering on behalf of the co-authors listed there. So a brief summary of MPT. It's a technology for creating a multipath traffic engineering tunnel from one or more ingress to one or more egresses. The signaling is primarily from a designated ingress or signaling source to each node in the tunnel and in the backward direction. The document, the draft so far, and this presentation will focus on the signaling the MPT tunnels using BGP environments in environments where other signaling protocols may not be available. There is more background in that draft, Compella, TS, MPTE. I'm going to quick go some 20 seconds on this picture here. We have a tunnel from R1 to R12 going through those 4 red paths. If you look at R2, it has 2 previous hubs to the same router using 2 links. and 3 next hubs, R3, R7, R9. There is a percentage number there. This indicates the load share. For example, 50% goes to R3 and 25% goes to R7, things like that. So the signal need to get the information to R2 and to every router on that tunnel. So the way we do it, we use a new CFI, we call it MPTE CFI. The NRI will encode the identification of the DAG, or another name for the tunnel, and the junction, and then some other informations like version or bandwidth, things like that. For the previous hubs and next hubs, or P hub, N hubs, and those information, we carry it in the tunnel encapsulation attributes. The routes, each route is targeted for, to a particular node. Those routes are propagated by the BGP infrastructure, either hub by hub or via route reflectors. The route target is used to target the routes at a particular junction, and the propagation will stop once it reaches that target. So I want to give a quick background on the tunnel encapsulation attributes. It was originally designed to specify encapsulation information for tunnels to the protocol next hop in a BGP update. If you look at this picture, we have two PEs, P1 and P2. There are 3 tunnels from P1 to P2. Here I intentionally listed the label switch path 1, a segment routing path 1, and then GRE tunnel 1. Let's say that any of those tunnels could be used. So the P2 put those information into the tunnel encapsulation attributes, listing OSP1, SR1, and GRE1. Looks like those lines are misaligned, but that's okay. So when the P1 receives it, the traffic is load balanced or selectively put onto those into different tunnels. Now each tunnel is represented by a TLV in that attribute. It has sub-TLVs to encode information specific to that tunnel or to that tunnel encapsulation type. Now, to use it for MPTE, we extend it so that it no longer represents tunnels to the protocol next hop. Instead, it encodes one or more forwarding branches as quote-unquote tunnels on multicast tree node or MPTE junction. The extension was actually done previously for the multicast purposes. We are basically reusing those extensions. Here, a quote-unquote tunnel can represent a real tunnel to a remote destination, or it can just represent an interface. In the multicast case, it could be an incoming interface, or it could be an outgoing interface. And MPTE case, it could be a P-hop or an N-hop. You can use different tunnel types for different encapsulations. For example, if you use an MPLS for MPTE, then it could be an MPLS label. You could use an IP tunnel. For MPTE, it could be a different kind of tunnel. So those extensions were already specified in the BGP multicast controller drafts, which uses a different CFI and for multicast purposes. Now, I want to clarify this new tunnel type we introduced. Previously, we mentioned that different tunnels have different encapsulations, MPLS tunnel or GRE tunnel, whatever. Here, sometimes one may not care the encapsulation you use. You can say, it could be that you can use any kind of encapsulation, GRE tunnel, MPLS tunnel, to reach that tunnel destination. Or it could be that you are doing the native forwarding out of an interface to your directly connected neighbor. That's why we introduced this tunnel type called any encapsulation tunnel, meaning that we don't care. As long as you can get my traffic to that node, that's fine. The name may be hard to follow, so we appreciate if you could have suggestions for a better name. Then coming back to MPTE, we need an identifier in the data plane to say that which traffic is, which tunnel or which stack this traffic belongs to. That data plane ID could be a label, could be a seed, or could be any other kind of data plane identifier. It's carried in the packet, just like a VPN label. It's signaled as a sub-TLV in a tunnel in that tunnel encapsulation attributes. So for the MPOS case, we use a tree label stack sub-TLV. That's what that was specified for multicast purposes, and that's why the tree label, the tree term was used there. Now for MPTE, we use the same for MPTE purpose because they are basically the same data plane identifier. So we could use a different name, better name, maybe back label, stack sub-TLV or something, but that's just naming issue. So why a label stack instead of a single label? In most cases, single label is enough. There are cases that maybe you want to use a label stack, and that's well explained in the multicast draft. Notice that even when you are using any encapsulation tunnel, or even GRE tunnel or UDP to get the traffic to your downstream next hop node, you could still use use any encapsulation tunnel with the label stack inside it for MPLS data plane. RPF sub TLV, again, it comes from the multicast work. In the multicast case, one of the tunnels carry that RPF sub TLV, which means reverse pass forwarding, indicates that this tunnel is really just an incoming interface. This sub TLV is just an indication with a length 0 with no value part. We may change that to define as flag sub TLV and use 1 bit in that flag field to indicate this this is RPF or upstream. For MPT, we use the same RPF sub TLV or flag to indicate the P hop. So maybe we'll change it to upstream sub TLV or upstream flag. And the weight sub TLV. Remember earlier, I pointed out that for each N hop, next hop, there is a percentage to indicate the load share. 50% goes this way, 25% go that way, so on and so forth. The draft currently says that we're going to use the weight sub TLV. It turns out that now we realize that that weight sub TLV in the RFC 9830 is specifically for SR policy segment list, and it comes from different registry. We cannot really use it. We will need a new sub TLV from the BGP tunnel encapsulation attribute sub TLV registry. We might also call it a load share sub TLV, things like that. But the weight sub TLV, the RPF sub TLV, and any encapsulation and tunnel type, all those, maybe we change the name, but still those are the main tunnel types or sub TLVs that we need you to use for the MPTE purposes.
Jeffrey, we've hit the end of your time. Why don't you give that slide and we'll call it quits? You almost made it on
Yeah.
time.
Yeah. So this is the 00 version, explains the concept and describe the procedures. We still have quite some work to do, some details to put in, and to give a very precise normative specification. Yeah. We'll continue that work. There are POC implementations going on, Junos-based and FRR based. So we appreciate your reviews, comments, and suggestions. Thanks.
We're going to have to cut it there. Thank you, Jeffrey. And by the way, this is tagged to some of the things that Jeffrey's described. Zephyr, I will have you come up. I'll just finish with Jeffrey. Some of Jeffrey's work comes out of the best draft, best multicast controller. Did I get the right name? Yep. grab a mic as we start someone else and grab it. Jeffrey's going to give you the name.
Yeah, drafts IETF BES BGP multicast controller.
Okay, thank you, Jeffrey. Zafar, it's your turn.
Hi, everyone. Let me know if there's any issue with the audio. My name is Zafar Ali. I'm from Cisco Systems. I'm going to present this draft on BGP services policy signals optimization advertisement on behalf of my co-authors. So I'd like to remind a little bit of a history. So this draft was presented 3 IETF back. And when it was presented, there was a feedback. And the feedback was really about need for Spring to establish the requirement that this work is something that Spring would like to do. So we were following that discussion. We tried to do a draft in Spring that were presented in subsequent IETFs, IETF 123 and 124. And that draft is now adopted work in Spring and it's been published at draft IETF. So just to give a very brief overview of that draft is that it's about segment services policies. And a services policy SID list may end with either a node SID or a particular hop agency SID. When the services segment list ends with a node SID as the last SID, and a service or some traffic that is steered over that policy also has node SID on the last SID with the same intent that carries the traffic there, then what happens is that the last node has to deal with back-to-back local SIDs. One is for the policy endpoint node SID, and one is for the, let's say, service. So this happen, for example, in the cases when you have a service carried over a services policies, or you have binding SID locator that carries the traffic to the end node SIDs. This was discussed in the spring and is not efficient from a compression efficiency point of view. So basically, what a Spring Draft describes is the need for work that a node, an ingress node, when it determines that the traffic is steered on that policy and takes it to the egress, can skip or eliminate the node SID in installing the policy. So the solution is for this draft is very, very simple. This is about advertisement in BGPLS that a node that has installed the policy and the ingress has actually skipped the last they skip the node SID that for the last node SID in installing the policy, and this is carried by a flag, and the flag goes under the candidate path TLB, and that is within the BGPLS advertisement. So the changes are fairly simple. There was another comment in IETF 122 that there's a complementary PSAP extension, and here like in IDR. So there was a comment about consistency across all the drafts, Spring, PCE, and IDR drafts, which is been done as well. The authors are not aware of any outstanding comment. Draft has been stable. So with that, the author would like the working group to have the work adopted to support the Spring base draft. Thank you.
So far, we've noted the adoption. I'm going to repeat what I said at the list earlier. We're trying to work through a number of drafts. the best way to get your draft adopted is comment on the other drafts on the list so we can move down the queue. We will try to run 4 or 5 at a time, but we need to at least complete those first work group. Any
Sounds good.
other
Thank you.
questions for Zafar? Any comment on this draft from the spring chairs, since it is adopted? This brings me to a good thing to mention. One of the things we've agreed with the spring chairs is that before you go through the adoption stage, that we're going to, no, come on up, I'm sorry. One of the things, if you use a spring concept, we're going to ask the drafts that are adopted to put in a section that says what spring function you map to. And I'm going to ask, I'll send it on a list, but we're going to ask for SR functions that you look at how it addresses spring and that how you interact with other features, such as maybe you use a PCE. I will explain that on the list, but it's a good moment to add that. Please go ahead.
Okay, thank you.
Thank you.
I'm Yang-Fei Guo from Zhongguancun Laboratory, and I will introduce my work on BGP communities for security policy intent. And here is the agenda. Let's begin with the background. The RPKI deployment is increasing. More than 40% AS have deployed RPKI, and about 60% prefix have been covered by RA. And route origin validation, RA for short, will produce 3 outcomes, including valid, not found, and invalid. The current security mechanism verify routing information, but they don't express the security expressions of the origin as. That means for example, if the source AS wants the downstream AS to drop the routes, if the RV result is not found or invalid, but the downstream AS have no idea because it can get the intent of the source AS. It will perform the routing decision by its local policy. So our solution is to standardize BGP large communities. It defines RA strict. It means that if the downstream AS receives the routes, it can reject the routes if the RPK RA result is invalid or not found. Here is an example. The route flow is from the left to the right, and the source AS can add the RA strict to the routes and broadcast it to all its downstream AS. And the downstream AS can make the routing decision with this large community. And here is some use case. The first one is large content networks may need this because when not found state is emerged, some attackers may hijack the routes. And the third is high-value target networks with RA strict, as can reject the suspicious reorigination. And the third is BGP monitoring. It can help to confirm the alert event with high confidence. And the last part is about security consideration. And the only thing need to be noted is the abuse of this mechanism. But fortunately, this is a file close problem. It won't influence other networks. And this is just a signal. And here is the conclusion. This is a lightweight mechanism to show origin as expectation. And that's all. Thank you. Any questions or comments?
Stephane's, you're first, Stefan. And then,
I'll try to be quick. Isn't it something that should be discussed in CyderOps?
Yes.
yeah,
But I haven't discussed there because I think this is a BGP large 90.
so this we just had that discussion on the list this morning. So yes,
Okay.
it would be with the CyderOps chairs. Charters are wonderful. This will need to go to CyderOps because we've identified that set of protocols are under their control. But please give him feedback as well.
Yeah, so
as he
I will provide the feedback. I think you may have a good intent in what you are trying to propose, but each time we propose a new tool in a security area, it can be misused and create, I would say, additional security holes, I would say. So I would say you can probably continue and we need to discuss more in details, but we really need to keep that in mind, that anything that we add could, I would say, create additional security issues for networks.
Okay, thank you.
Really short.
And I have a small question because you mentioned it have a out-of-band mechanism such as RPK object and might eventually be a better fit. So how should we position this large community approach? Is it intended mainly as an incremental deployment step, or do you think it as the long-term mechanism for a signal or region security intent?
Okay, thank you. Because this is just an idea. I haven't mentioned it in the pre. I will discuss with you later.
May I ask
Okay.
you guys to go and discuss that, because right now we're out of time. Would that be okay?
Okay.
That would be wonderful. And you will need to apply to CyderUp for standardization in this area. Thank you.
Thank you.
Okay, I'm afraid it's my turn. Do you think you can pull up the chair slides again? I left you with a set of questions at the beginning. G's going to bring them up. I'm sure we'll just go to the end, but this is the time when the AD who's online, the other chairs, and we listen to what you do and do not want in the IDR charter. Stefan's given us a point that we should not go back into any BGP auto configuration at a lower point. If you agree with that, that's something to let us know. That's not in the charter at this time. If you want it in the charter, it needs to be there. We had done that almost 5 years ago, and that work moved over to LSVR. Okay, because there was more synergy there. There's an L3 DL, I think, right? Did I get the right name, G? Yeah, L3DL, since I'm a co-author. So please, there's some work with that ongoing for LSR. So whose proposal didn't fit within that one? So there are other places, but please give us feedback. If you're feeling shy, you don't have to speak at the mic. And now I'll leave it open for anyone who'd like to speak. The charter is online. I did give you a, let me give this. Here's the charter. Please take a look at it. Putting the charter on the screen and squinting at it doesn't work as well as you just clicking on it. It's a different style, but other than leaving the things we had already left out, it's pretty much the same. We tried to keep it the same. Caton, is there anything you'd like to say?
Yeah, I think just to clarify on what you said. The intent here has been to kind of take in all the adopted work that is there currently and all the work that is being done. It's just being listed out explicitly because, as Sue mentioned, every IESG is different. And what we are seeing is that there are questions about whether the work is in charter or not being raised. And if that happens late when the document comes to IESG, it's a problem that we want to avoid. So that's really about it. So anything that we are doing that is not captured here, please bring it to our attention.
Okay, I'll go back to some of the things people have said to me. Okay. How do we hand off? You notice that IDR is trying to be effective. You've got a lot of really good ideas, and we're really grateful for all of them. We're trying to effectively process things through that have been adopted and implemented and adopt more in so we can help refine them and get stuff in. Please, we're still concerned. I think some of the SR V6 people, one of the drafts was composite link, found out that I'm really interested in scaling and what happens. And we're all interested in interoperability, as Stefan is talking, or as Jeff has mentioned. If there is something already implemented, IDR tends to say, why don't you use what we've done? That's usually one of the questions you will get when you come to us. Anything else for the charter? We will sit here for a minute while you stare at your screen and see if there's anything. This is one time we're going to wait in quietness. If you're online, just go ahead.
Jump in on the mic, and there's a little bit of chat. The channel, a couple of the comments from channeling Dan Voyer is like IDR is a bit too wide and might be worth optimizing things to move some of the work elsewhere. The response I gave to him in the chat that you're covering, Sue, is that this is a shared technology. Moving around who does the work at least makes IDR potentially move smoother in terms of what work is done where, but it doesn't necessarily address the problem of this is a shared technology, and simply moving around who does the work doesn't necessarily please don't break me. So that piece of the issue needs to be addressed regardless of who does the work.
This is one time we'd love to hear more comments, but if it's a process, if you are feeling like you'd like to think about it and send us notes, please do. What will it affect our daily life? Because we're not doing much we haven't really made a dramatic change. So we're still just going to keep pushing forward to refine drafts, to ask questions. Go ahead, Stefan.
One very small question. Any deadline to close that?
One more time.
Any deadline? Do you have any target when you want the charter to be updated?
Yes, Caitlin, what's the deadline for the charter?
So we've been talking about this for 3 IETFs. Sooner would be better. My concern is that some of the other documents that are coming up to ISG may not fit in the letter of the charter, of the current charter. So I would say yesterday. But the key part is that we try to move forward with whatever we get, kind of consensus or agreement on. And obviously we tweak things as we go. Nothing is cast in stone here and right now.
So probably, Ketan, you should, or the chair should really put some deadline like we do, for instance, for adoption calls or anything, so you can gather feedback. If you don't have any deadline, people will just take their time, never provide feedback.
Caitlin, I think we'll talk offline and set a deadline. I tend to send, a 3-week deadline and say that's it. But you're my AD, so I'm sure you'll give me some wisdom. Okay, well, in which case, you've got back 1 whole minute of your life from IDR. Thank you very much for attending. Please, if you wanted to talk more at the mic and we had to really drive through this, please go ahead and talk to the person you wanted to discuss. Thank you very much. Oh, we will have a session on Friday, as always, so please join that one. I believe it's the first session there, so there will be lots more drafts and lots of good SRV6, lots of good low spec, and lots of good other drafts.